I want to talk to you about some of the dangers with welding gases and oxygen. Today we're going to focus on some of the most common gases in the workplace, gases that you might use every day. Specifically, the popular gases that I want to talk to you about are propane and later in this presentation, oxygen. First, let's talk about propane. Propane is a popular fuel gas in many industrial processes, including flame cutting, preheating, and extensively in material handling equipment like lift trucks, etc. A concept that many people do not realize is that many fuel gases are heavier than air. What this means is anytime you have a leak, the gas can gather, creating a potentially very dangerous situation. The gases can fill up drains or sewer lines and be ignited by the tiniest of sparks, even static electricity. A good example is when a residence has a natural gas leak and someone attempts to turn on the stove or oven. The accumulation of the leaking natural gas can have devastating effects. We've all seen the unfortunate aftermath of this type of situation on the news. Now, propane gas is one of the heaviest of all fuel gases commonly used, and any leak can be extremely dangerous. It is from a tank used for welding or from a tow motor or other uses. It will have the same potential effects. I'm going to do a demonstration for you now to show that fuel gases are heavier than air. What I have here are two ordinary Pilsner glasses made of glass. These glasses are clean and empty and contain nothing except air. I'll demonstrate that now by attempting to ignite what is in the glass. Obviously, these glasses are empty. Now I'm going to add propane to one glass using my torch. That should be enough. So I have one glass containing propane and one empty glass. To further show that the fuel gas is heavier than air, I'll now pour the propane in the glass I just filled into the empty glass. Although you cannot see it, the fuel gas is pouring like water from the first glass into the second glass. Now let's see what happens when an ignition source such as a spark or flame is exposed to the leak we have simulated. As you can see by the flame from the glass that the propane we leaked into the first glass and then poured into the second glass was heavier than air and remained in the confined space within the glass until it encountered a source of ignition. To further show how the gas was poured from the first glass into the second glass, let's try to ignite the first glass. This is not a magic trick. The fuel gas that was in glass 1 originally obviously was poured out and into the second glass. Whether the leak came from a welding application or a tank on something such as a tow motor, the danger is the same and very real. If propane or many other fuel gases are allowed to leak, they will accumulate in drains, sewers, or any low place on the floor, setting you up for serious fire or explosion. That is why all connections, not just those using flammable gases, should be leak tested only by an approved leak test solution before being put into use.